Hello, good afternoon, everyone.
Good afternoon, sir.
Okay, how are you all doing?
Sir, please, we are all fine.
Okay, good. We thank God. Welcome to today's class. Today we are looking at the operating system structures. I'm sure last time we completed the chapter 1, right?
Yes, please, sir.
Yes, please.
Okay, so today we are starting with the operating system structures, and this is the outline for today's class. We are going to talk about the services that the operating system renders. Then we look at the different interfaces, okay, how the operating system is divided into modes, then a few on system calls and system services, okay. Then we will talk about linkers and loaders and why applications are operating system specific. So by the end of today's class, I'm expecting that you will be able to identify the services provided by an operating system and also illustrate how system calls are used to provide operating system services. Now, before we start today's class, from what we did last week, are there any concerns, questions, challenges, or contributions that you want to share? All right. If there are no questions or contributions, I guess we can continue. So remember that the operating system provides an environment where users can execute their programs and also an environment where other services can also render their services to user programs as well as the operating system itself. Now, there are two aspects of the operating system when you look at it from the functions that it performs. There are functions that it performs to help the user and also functions that it performs to help the system, that is the computer system, okay? Now, when it comes to the functions that the operating system performs in order to help the user, okay, remember we have said that the operating system provides convenience for the user. And what are the functions that it performs in order to provide that convenience? The first one is that the operating system provides the user interface. So all the user interfaces that you see, you want to save a file, you click on file, save, and then a user save as dialog box appears. You want to print, you click on print, and then you get a print dialog box. It is the operating system that provides the user interfaces that we see in the computer system. Okay, these user interfaces vary. There could be some form of command line. There could be graphical user interfaces that you usually see. the touch screen that we use in our phones, they are all some form of user interfaces that the operating system provides. There's also the batch. Okay. The operating system also allows the user to execute programs. Okay. Everything that we do on the computer system or on our phones, a way of executing programs. You want to make a call, you click on the phone app, the phone app appears, you make your call. You want to what do you call it? Use the calculator. You want to use Facebook. You want to use Internet Explorer. You want to use Mozilla. All these are programs that are executed, and it is the operating system that allows us or provides the enabling environment for us to execute the program. The operating system also provides the input-output operations. Okay, you want to input data into the computer system, you do it through the operating system. You want to get an output from your computer system, it comes through the operating system. The operating system also allows us to access the file system in the computer system. So you have the reading of files, creating of files, editing of files, deleting of files. All these operations are provided by the operating system on the computer. Also, we have the operating system allowing or providing the means for communication. Okay, here we are talking about processes. If the process in the computer system must communicate, you have process A, process B. If they have to communicate by way of exchanging information, it is the operating system that enables or that ensures or that provides the enabling environment for these processes to execute. Also, if a process creates sub-process or children processes, they must share data because they belong to the same parent. This is called the intra-process communication. That is also provided by the operating system. Okay, this communication may happen either through shared memory, okay, or through message passing. When we say shared memory, the two processes that are communicating, for example, process A and process B, okay, they enable their memory access to each other so that they can share data via the same channel. If A wants to communicate with B, A can write into B's memory location and vice versa. That is the shared memory. Or they may have a memory location that is shared by the two processes. So if A wants to send any communication, any data to B, okay, they will write it to that shared memory and B will also have access to it. So B will get it. That is the shared memory. Then we also have the message passing. In the message passing, you have a process A wanting to communicate with process B. And this is done through message. So process A will actually send a message to process B with the information that A wants to communicate. We'll talk more about these two modes of communication later in this course. Okay. An example of this message passing are the packets that are sent over the internet when you want to communicate. As we speak, my speech is packaged in packets and it is broken down into pieces and sent to you, okay, through message passing. The operating system also allows for or is the one that detects error in the computer system. Okay? The operating system needs to be constantly aware of possible errors. These errors may occur in the central processing unit. It may occur in the memory hardware. It may occur in the input-output devices or even in the user program. Okay, because of these varying types of errors, the operating system should take the appropriate. So it must first detect what type of error the error is, and then the appropriate action must be taken in order to correct the error, okay, to provide consistent computing. The operating system also allows for debugging. So it provides you the environment to debug a program. I'm sure we have all debugged a program before, right? Abdul, Yakubu, have you debugged a program before? Tell us which one, please.
During this one, let me say, when writing a program and to find out that there is an error in the program,
Okay.
you debug it using the compiler or something.
Okay. Okay. All right. So okay. So thank you. The debugging is actually the process of you correcting the error. So assuming you write a C program like you rightly said, and then the C program, after the compilation, you realize that there is an error in the program. You attempt to correct that error. That process of you correcting the error is what we call the debugging. It is the operating system that provides the facilities that allows us to debug. Okay, okay, that's fine. So those are the functions that the operating system performs in order to provide the user with that convenience. Okay, there is another set of functions that the operating system performs in order to ensure efficient use of the resources on the computer system. Okay, so for the user, it is convenience. For the computer system, it is efficiency. Okay, so that the resources on the computer system can be efficiently used. Okay, and these functions are as follows. The first one is the resource allocation. Okay, because you have multiple users on the computer system, all using the limited resources on the computer. For example, there's only one CPU. Okay, and this CPU must be used by all the processes in the computer system. There is only one memory, and all this memory will be used by all the programs in the computer system. So you realize that it's not just a simple task. Operating system has a lot to do when it comes to the memory allocation. Okay, there's also what we call the accounting or logging. This is provided by the operating system in order to keep track of what users are doing on the computer system. So who used which resource? When did you use that resource? How did you use that resource? Okay, so all these are tracked by the operating system. That is why I can come into your computer, I can go to a place that you may not be aware of and tell you what you have been doing with your computer for the past 1 year. Okay, it is the operating system that keeps track of all these activities on the computer system for auditing purposes or for reference. Operating system also provides protection and security. Okay, so you have the owners of information stored in a multi-user or networked computer may want to control how that information is used. You have your computer, you have your data, you have your photos, you have your videos, you have your documents. All these are on the computer system. You need the computer, you need the operating system to provide some form of security for this information that you have in the computer system. So when it comes to um, the security, there are two. We have protection and security. Protection has to do with the system resources. Then the security has to do with the files, okay, that you have on the computer system, and also the users when it comes to authentication and all that. All these functions are provided by the operating system in order to ensure efficient use of the resources on the computer system. You with me? Do you understand what is going on? Are there any questions? Okay, if there are no questions, I guess we can continue. So when you break these functionalities down, or when you put them all together, you can represent them in this diagram. The diagram here represents all the functionalities that we've talked about, both on behalf of the user for convenience and for efficient use of the computer resources. So the ones that are in yellow background, yellow borders, all right, they are the ones that are provided by the operating system to ensure the efficient use of the computer system. And then the ones with the black borders, they are the ones that are provided by the operating system for convenience on the user, okay? Then all these services, all these functionalities, okay, are accessed through system calls. So these are the various user, what do you call it, interfaces. You have the graphical user interface, you have the batch, you have the command line. All these are user interfaces. So whichever user interface that you belong to, you are able to access these functionalities with the help of system calls. Okay, you don't just access them directly. And so we're going to take some time to look at system calls. Okay, all right. If there are no questions, let's look at the user interfaces, the components that we mentioned. Let's take some time to look at them. We've mentioned the command line interpreter. Okay, has anyone used the command line interpreter before?
Yes, sir.
Okay, tell me. Yes, can you tell me about the command line interpreter that you used? Which one you used?
Okay, so that was the Linux system, that is Kali or Ubuntu.
Okay, all right.
So even if when you want to install a program, you need to input some command like sudo apt install and the program name before you can install the program. It's not like Windows that you get the setup from website and you just install it.
Okay, all right. Thank you, Asamoah Kelvin. Okay, good. Thank you for that contribution. I think it's on point. Now, some operating systems include the command interpreter in the kernel. Okay, there are others such as the Windows and the Unix operating systems. They treat the command interpreter as a special program. Okay, that is run when a job is created. So I'm sure you on Windows, you may have come across the command prompt, the CMD. Okay. Okay, good. So this command line interpreter allows direct command entry. You know, when you double click on an application, your double click is actually not the one that opens the application. That icon that you are double clicking on is only a shortcut. When you double click, there is a command that is executed on behalf of your double click behind the scenes. Okay, so for example, if you are double clicking on Mozilla Firefox, there is a command that is executed to call the Mozilla Firefox before it starts on the computer. Now, alternative to this double clicking, that is using the mouse to double click or to click on a file, you can, if you know the command, you can use the command to actually execute the application directly. Okay. Now, Are you with me?
Yes, sir.
I'm going to change. I'm going to change. Theo, please mute your mic. Theophilus Awua, please mute your mic. Thank you. Okay, so I'm going to share my screen. I'm going to share my screen now for you to see what is actually going on. For you to see my entire screen. And then I'll execute a command for you to see and understand what I mean. I hope you can see my screen now.
No, sir.
You can't see my screen.
We can see it now.
You can see the entire screen, right? Okay, so you know that when I do Windows R, a Windows plus the R key, I get my command.
Sir, please.
Yes. Can you all see my Windows?
Yes, sir. Yes, sir.
No, sir.
Do you see the run command? This command here, do you see it?
Yes, sir.
Good.
Yes, sir.
Okay, so when I type CMD, that is a command that is going to open the command prompt for me. I'm sure you can see the command prompt.
Yes, sir.
Very good. Very good. Now, before I go to the command prompt, you know that if you want to open the calculator, okay, usually you go to start and then you look for the calculator icon here, right? I hope you can see the calculator.
Yes, sir.
Good. And then what do you do? Okay, good. So you click on the calculator and the calculator application has opened. I hope you can see the calculator now.
Yes, sir.
Very good. So I'm going to close this. So this is the graphical user interface. In the behind the clicking of the calculator, there is a command that is actually executed. But in order to make things easier and simple for the user, remember, the operating system provides convenience. So in order to make things easier for the ordinary user, they hide all these commands behind the scene so that they give you an icon to click on for your calculator to open, or any application for that matter. But this, as you see here, is the command prompt. Okay, now if you knew the command, instead of clicking on the mouse, instead of clicking on the calculator to open the calculator, you can actually execute the command. You can use the command to open a calculator. So the command to open the calculator is CALC, calc. Okay, when I press enter now, it will open the calculator app just like when I clicked on it. So you can see that the calculator is opening, right? It has opened now. The command is calc. Okay, I hope you've gotten this demonstration.
Yes.
All right, very good. Again, let me use the command prompt to execute another application. Assuming you want to open Notepad, you can simply type Notepad here and press enter. It will open the Notepad for you. Okay, if you want to open the let's say MS Paint, you can just type MS Paint and it will open the Paint application for you. Do you understand? So all I'm trying to say is that there is something we call the command prompt. This is used to execute commands directly. So instead of using the mouse, if you know the commands for any operation or any activity, you can use this command prompt. Okay, so I'm going to reverse the screen sharing to test the slide, and we will continue from there. Okay, so I'm going to take it back to my PowerPoint show, and then here we go. Okay, so now let's go back to our note. It says that the CLI, that is the command line interpreter, allows you to directly enter a command. Okay, this is sometimes implemented in the kernel. So now what it means is that you see the command prompt that I open, that black screen, that sometimes the interpretation for some of the commands that we enter are inside the command prompt itself. Okay, I guess let me go back and share the screen again. Guys, please mute your mic. Hillary, thank you. Okay, so I hope you can see my entire screen now. Let me pick the command prompt again. So you see, what we are saying is that sometimes this command prompt is having the interpretation for some of the commands that we enter. For example, if I enter dir, dir is a command that is telling the system to list all the directories in my computer system, in my current folder. Currently, I am in the Kwajo folder or the Kwajo directory. Kwajo directory is in the users directory. The users directory is in the drive C. If I type dir, all the folders in the Kwajo directory are shown here. As you can see, these are the directories that you see in my Kwajo directory. Now, the interpretation of this dir is inside this command prompt. So when you type dir, this dir, the command prompt does not go anywhere, but it executes it directly without even calling the kernel. You understand? Then there are other commands whose interpretation is not in this command prompt. Like when I entered the notepad is a call, is a command that is going to call an application. This notepad is a program that is sitting in the computer system. So when you execute the notepad command, it will go, the command prompt will go outside the command prompt and execute the notepad application. Okay, so that is what it's saying here. Sometimes the commands are implemented in the kernel itself. Sometimes it's implemented by systems program. Okay, the command interpreter itself contains sometimes the command interpreter itself. So there are two ways. The command interpreter itself may contain the code to execute the command, like I told you about the dir. And then other times, the command interpreter will implement these commands through other system programs. Okay, so that is the command line interpreter, or the CLI. Okay, good. Let's continue. If there are no questions, can we continue?
Yes, sir.
Good. All right. So these command line interpreters, there are different flavors depending on the system, the operating system that you are using. Okay. So we have, for example, I'm sure you have heard of the Bourne shell. The Bourne shell, that is an example of the command prompt. We also have the C shell. Okay, the C shell is also an example of the command prompt. We have the born again shell. The born again shell. Those of you who have used Unix operating system before, this born again shell is what you usually refer to as the bash command prompt. So the command line that you often use in the Unix Linux environment is the born again shell, or the bash. We also have the corn shell. All these are different types of command line interpreters that are used in the different operating systems. Okay, okay, good. Let's move on to the graphical user interface. So instead of entering the commands like we just did, in the command prompt, you have to memorize all the commands for every program that you want to execute, and that can be very, very tedious or difficult. Okay, so rather than entering the commands directly into the command line, we have the excuse me, we have the graphical user interface, or the GUI. We can call it the GUI, 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 GUI. The GUI employs a mouse-based window and menu system characterized by a desktop metaphor. So you have a mouse-based window. Okay, you are also provided with a menu so that you use the mouse to select the menu. Okay, the options that are given in the menu, use the mouse to select. Then you have a window-based system where you can your entire computer is like a window. Okay, so GUI first appeared in the 1970s at a research facility called the Xerox Park. Okay, then the first GUI appeared on the Xerox Alto computer in 1973, right? Then GUI became more widespread with the advent of Apple Macintosh in the 80s, in the 1980s. Microsoft's first version of Windows, okay, was based on the addition of a GUI interface. You've talked about the MS-DOS. Remember last week we talked about the MS-DOS, and Microsoft built the GUI interface on its MS-DOS operating system, and it became Microsoft Windows. A moment, please. That's why it's that. Right. Yeah, that's why. Thank you. All right. So remember that it was Apple that actually first used the GUI. Okay. Then of course there is Unix and Linux operating system that also have the optional GNOME and the KDE GUI interfaces. All these are examples of the GUI. Okay. Good. Any questions, please? Any questions, please?
No, sir.
Good. All right. Now, if there are no questions, then let's look at system calls. Now, when we looked at the services the operating system performs to both the user and the computer system, we saw that all these services were accessed by the user with the help of system calls. So we're going to spend some time to talk about system calls. All right. Good. Look at this example program here. It is a very simple program to read data from one file and copy it to another file. So there is a source file and there is a destination file. In order to make this work, the computer has to go through the operating system, or the program that is trying to do that copy and paste will have to go through a series of tests or a series of activities. The first is to get the input right to the screen accept the inputs. You know how to do copy and paste. You right click and all that. Now it has been made simple. But these are the steps that are actually, followed when you want to do copy and paste. You open the file, you select, you right click, you copy, you open the destination file, you go there and you paste. If the destination file is not there, you create it and all that. All the activities that are performed in this operation are system calls. So system calls provide an interface to the operating system services. These system calls are typically written in high-level languages, such as the C and C++. Okay. Now, the activities that we perform in the computer system, a lot of them, okay, execute millions and thousands of system calls per second. Let's imagine what I'm doing, moving my mouse all over this slide. Okay, they are all system calls. You get a call on your phone, it's a system call. Okay, you move your hand, you touch your screen, you do that, you press a button. Everything that you do, because it is the operating system that interfaces between the user and the hardware. And as a user, because you cannot physically touch the hardware to perform any activity, it is the operating system that does that on behalf of the user. And this is done through system call, right? Any questions? Okay. Now, looking at the system calls that are executed when you want to copy one file to another file. All these things, all these system calls that we've talked about or we've seen will happen on the blind side of the user. And also, as a programmer, you may not be concerned about this level of detail. Why? Because as a programmer, you don't need to know all these system calls. Imagine if you have to write a program and you must be concerned with all these system calls. You can't. Okay. So there are some interfaces that are created by other third-party vendors. These interfaces are called the Application Program Interface, simply API. These API are developed by some vendor that will interface between the program the programmer and the operating system. So as a programmer, if you want to copy a file, perhaps you just give the command copy. This command copy is sent to the API. The API will go into the operating system and execute all the necessary system calls on behalf of the programmer. So me, I don't know the details. All I know is that when I give a command copy, I can copy a file. When I give a command paste, I can paste a file. So this is the programmer line up here. This is the API. I'm going to just label it A. This is the API. So the programmer will just give the command copy to the API. Then the API will enter into the operating system and execute all the necessary system calls in order for the copy to be possible. If I give paste to the API will also go into the operating system and execute all the necessary system calls in order for the paste to happen. Okay, so the API specifies a set of functions that are available to an application programmer, including the parameters that are to be passed. So if I want to copy, I can give it a parameter. What do I want to copy? Okay, so that may come in a parameter, okay, as a function. Okay, if I want to paste, where do I want to paste? That may also come into a parameter. So the API will tell you if you want to copy, you give these as your parameters. If you want to paste, you give these as your parameters. Okay, so as a programmer, you no longer need to worry about the system calls. Okay. Guys, excuse me, please. Yes. Okay, I thought somebody raised their hand, but okay, nobody has raised their hand, so let's go on. So there are three common APIs that are used by application programmers. Okay, we have the Win32 API that are usually for the Windows system. Then we have the POSIX API. This is for POSIX-based computer systems like the Linux, the Unix, and the Mac OS. Then we have the Java API. This is the Java virtual machine. I'm sure if you have done Java programming before, you know of the Java API. Okay, so these are the most commonly used APIs that programmers are familiar with. So what do you want to do? If you are programming in the Windows and assuming you want to create a file, okay, this Win32 will give you a function that if you want to create a file, use, for example, the command create. Okay, so when I give create, and perhaps I give a parameter as in the name of the file that I want to create. When I give this command to the Win32, Win32 will take the command and execute all the necessary system calls in the operating system. Okay, so the API invokes the actual system calls on behalf of the application programmer. Guys, are you with me? Any questions? All right, good. That's fine. Let's go on then. Now look at this example here. These are two functions on different APIs performing the same activity. Okay, so the first one is the POSIX API, that is the Unix and Linux system. Then we have the next one, the second one here is the Win32 API. Okay, that works on the Windows-based applications or operating system. Now you notice here that we have the read function, okay, on the Unix environment and the read file. All these are performing the same activity. So for the Unix-based systems, you have how many parameters? One, that is the FD, the buffer, 2, and the count. These are three parameters that you pass in order to read a file in the Unix environment. If you bring it to the Windows environment, the same reading of file, you have the file, these are parameters, the file, the buffer, the bytes to read, the bytes read, and the OVL. Okay, that is how many, if there is an overlap, the OVL. So these are the different functions, but performing the same activity or operation, both on the Windows operating system and the Unix operating system. Okay, we'll come back to this example very soon. So as a programmer, once you give the read, it will do it for you. or you give the read file, it will do it for you. All the necessary system calls will be performed by these two APIs on behalf of you, the programmer. Okay. All right. Now, why is it necessary that as a programmer you execute system calls through an API rather than doing your own system call? Okay, there are two main reasons. The first one is that you want to have program portability. What is program portability? If you have a window-based computer system and I write a program and I'm using the program to read a file, okay, when I execute this in my program, if it is Windows 8 and it understands Windows 30, the Win32 API, my program will run on Windows 8. If it is Windows 10 and Windows 10 understands the Win32 API, my program will run on Windows 10. If it is Windows 7 and Windows 7 understands the Win32 API, my program will run on Windows 7. So that is portability. You write your program once and it runs on all. But you see, we will soon talk about the reason you have Windows application not running on the Linux operating system and vice versa. This is because of the system calls that are executed when you want to perform some activities. So you notice that if I write a program with read file, this read file is not understood by read on the Unix environment. Therefore, my window-based application will not run. The second reason why a programmer will prefer to use an API is that the actual system calls can be more detailed and difficult to work with. Okay, so you don't want to worry yourself so much about some complex system calls. Just stick with what the API provides and you are good to go. Okay, now we have some compilers that have a set of functions built into their libraries, okay, that can also perform system calls. So apart from the APIs, if you have a compiler, the compiler can also give you some codes to write and it will perform system calls on behalf of your program. That is why we use compiler like the Borland C++. That is a compiler. So when we give this cout, excuse me, when we give the Borland compiler, that is C++ compiler, when we give it this command cout, this cout is converted into the appropriate system call by the Borland C++ compiler. Okay. The system call interface will intercept calls in the API and it will invoke the necessary system calls within the operating system. Okay, so that way, most of the details of the operating system are hidden from the programmer. So you don't want to worry yourself about what system calls to execute. Just stick with an API or a compiler and you are good to go. Okay, so this is the diagram that is depicting what we have talked about so far. This is your user program. It gives you a very simple, the API gives you a very simple command like open. This command is very simple to remember, easy to use. Okay, if this is given to your API, the API will actually execute the actual system call on behalf of you, the programmer. Okay. Now let's look at the types of system calls there are in the computer system, or sorry, in the operating system. So system calls can be grouped roughly into 6 major categories. We have the process control, the file manipulation, system calls for device manipulation, system calls for information maintenance, system calls for communications, and then system calls for protection, okay, of the computer system. Let's see if we can go through them one after the other. Let's look at the system calls for the process control. That was the first one. Remember, we have system calls for process control. So when it comes to process control, we have system calls to create a process, to terminate a process, to end a process, to abort a process, to load a process, execute, get the attributes of a process, set the attribute of a process, wait for time, how much time a process has waited, okay, wait event, signal a process. If you want to signal a process, we have system calls to do that, to allocate memory to a process, and also to recoup or free memory that has been allocated to a process. We can use a system call to dump memory in case there is an error. If a process encounters an error, how do you deal with that memory location that has been given to the process? Okay, all these are system calls that are used to control processes in the computer system. Okay, we talk about these later, forget about them for now. Okay, then when it comes to file manipulation, we have system calls to create a file, delete a file, open a file, close a file, read a file, write to a file, reposition. This reposition is, you see, when you are reading a file, assuming you have, this is a file, you have read line 1, 2, 3, 4, 5. The reposition can actually, assuming you are in line 5, somewhere here, the reposition can actually help you move the cursor forward or backwards. That is the reposition. Okay, we have the system call to do that. We also use system calls to get the attribute of a file and also set the attribute of a file. There are system calls for device management. When it comes to the management of the devices on the computer system, we have system calls to request a particular device, to release a device, to read from a device, to write to a device, to reposition, just like you reposition in a file, get the attribute and set the attribute of devices, and also logically attach or detach devices. That is why when you insert your pen drive, you hear a sound, "Poo," meaning your pen drive has been connected. When you are done with your pen drive, you can actually right click and logically detach. So it says safely remove pen drive. Immediately you click on safely remove pen drive. Even though you have not removed the pen drive, you will not see the pen drive in your computer again because it has been logically detached from your computer system. All these are done through system calls. And then when it comes to information maintenance, you can set time or get time, set date or set dates, okay, get the system data, get or set the system data, get and set process attribute, get and set file attribute, get and set device attribute. When it comes to communication, you can use system calls to create or delete communication channels. You can use system calls to send message, receive message. You can use any of the message passing model. Okay, you can use the you can use the message passing. You can use the shared memory. Message passing means one process sends a message to another. Shared memory means that you have a memory that is shared by the two processes or the processes that want to communicate, and they will put the data in that memory location. We can use system calls to transfer status information and also attach and detach remote devices. That is why I can be here and be managing a switch in Accra, and I can turn off the switch from here. I can restart the switch. I can reconfigure the switch. All these as a result of the system calls in the communication. Okay. Then when it comes to the protection of our computer system, we can use system calls to control the access of the resources in the computer system. We can use system calls to get the permissions and set the permissions of resources. We can use system calls to allow and deny user access. Okay, so these are the system calls that we can use when it comes to the protection. Now, if you look at this diagram here, this is a summary of all the system calls under the various categories we've talked about, both Windows and Unix. Okay, so process control in Windows, these are the system calls: create process. Its equivalent in Unix is fork. Exit process in Windows, its equivalent in Unix is exit. Wait for single object, its equivalent in Unix is wait. Okay, so this here also tells you why Windows-based applications cannot work on Unix-based applications. If I write a program in Windows, I want to create a process, it uses create process. On Linux machines, they don't understand create process. I must use fork. If I do it on Linux and I do fork, when it comes to computer, it cannot understand it. I mean, Windows-based, it will not understand it. So these are the reasons why you have computer applications that are developed for a particular operating system, not compatible with other types of operating system. Okay, so this will bring us, if you want your application to be multi-operating system application, then you must write your program not in a programming language, but it should be written guys. I'm here. Oh. I'm here. I'm here. Can you hear me? Okay, but I am currently not the host. I think my network went off, but it's back now. So let's continue. Is that okay?
Yes, sir.
Okay,
Just
good.
go back a little bit, because we could
So if you want your applications to run on multiple operating systems, that is like you want it to run on Unix-based computers and Windows-based computers, then you should write your program in an interpreted language like the Python, like the Ruby. Okay, you know what an interpreter does? An interpreter tries to execute your code line by line directly. So instead of converting, if you write a program in C, for example, when you compile, a compiler tries to convert your code into an object code. If you write a program in C, you save it as .c. After compilation, you see that your program has been converted to an object file. So the name will be .obj. This object file has been, is your source code that has been converted. But if you give your program to an interpreter, it does not do any conversion. An interpreter tries to execute the code directly. Okay, so if you want your program to be multi-operating system enabled, then you should write your application in an interpreted language. Example of these interpreted languages are the Python, the Ruby, the PHP, etc. You should also write your application in virtual machines, in languages that are virtual machine enabled, like Java. When you write a program in Java, it can be interpreted or it can be executed on both the Windows-based operating system and the Unix operating system, because all these have the Java virtual machine. Okay. You can also use a standard language like the C. Okay. When you use a standard language like the C, Then you can take it to Windows operating system and compile it for Windows, and then you compile it for Linux. Because this C program has compilers or interpreters both in the Windows-based and the Unix-based. If you take an application like the Visual Basic.net, if you want, it's not compatible on the Linux operating system because it cannot be compiled on the Linux operating system. So these are the reasons we have applications being operating system specific. Okay. All right. Any questions? If there are no questions, that will bring us to the end of today's class. Okay, Boydo, you have raised your hand. Please go ahead.
Yes, sir. I said, please, I wanted to ask concerning the other types of the system calls, especially the device management. You see, when you sometimes the drive gets locked